Hello, in this lab we will be working with backup, restoring and upgrading a Kubernetes cluster. So our first task will be to backup and restore a Kubernetes cluster. So if we take a simple scenario of backing up or restoring a file, first we will back up our file and then delete it, and then to check if it is really works, we restore that file to verify that our backup is completed. So the same thing is done in the Kubernetes cluster. We know that our state is stored in the etcd. Kubernetes cluster state is stored in the etcd. So first we will create a snapshot and store the etcd key value pair, means all the information related to Kubernetes cluster, that these pods, these containers are present in this node. All this information related to that, the snapshot of that information we will get from the etcd and store that information in our disk. And for that we will use etcd command to interact with the etcd to get key value pair. Then we store this snapshot and delete all the etcd data, all the nodes that are present, all the data in the Kubernetes cluster we deleted, and then we perform a backup. Then we restore by performing a backup from where we have stored the backup. This is our first task of backup and restoring a Kubernetes cluster. Then our next task is to upgrade our Kubernetes cluster. Means there is some new version of Kubernetes come, that is 1.2, 24.3 to 1.25.3. So to upgrade the Kubernetes cluster, it work in a series of steps. That is, first we will upgrade our kubeadm, which is used for deployment purposes, because we will be deploying new version of the Kubernetes. So first we will upgrade our kubeadm, then we will upgrade the control panel components, means the etcd. We know that in control panel what things are present: etcd, manager, and scheduler. These all things we will upgrade these things first of all, and then we will upgrade our network plugins, and then we will upgrade our Kubernetes packages that include kubelet, kubeadm, and kubectl. Kubeadm we have already upgraded, but these things will be upgraded in the third step. And then we will upgrade the kubelet configuration on worker nodes, means all the worker nodes will be upgraded in the last step. So this is the series of steps that we have to upgrade. These all things we can also automate in our code, and these all things can be performed on an automation process, and we can also uh, do the same thing in the backup process also. We can also schedule backup in a timely manner and create a file for this timely manner, but for this lab purposes we will be doing all these things with the manual procedure. So this is the first step of our lab, that is for here for the lab purposes we have taken an application and deployed that application with two replicas. So this is our first step, that is we have deployed our application with two replicas and expose the deployment using cluster IP so that we can alter the changes, then send a HTTP request to the web service to know that it is working fine before performing any backup or restoring process. So now we will list all the pods that are running in the namespace to ensure that before performing a backup all the pods are running healthy, and there is nothing wrong with any pod, because we are storing the states of before we are storing the state of every node, everything. We will be checking that everything is working fine. Then we will create a job and issue the etcd snapshot to save command to backup the cluster, means all the things will be all the key value pair will be stored by etcd. So for that we will generate a etcd ctl command to interact with the etcd. So this job is created. Similarly, we can add one more functionality to this job to perform a backup operation in a timely manner. But for this lab purpose, we are doing a manual backup. Then we list the content of the snapshot directory. That is this. This will store the all the key value pairs from the etcdl to the snapshot directory. Means the state of the etcd will be stored. So we will check that the state has been stored. So we will look into the a snapshot directory that backup.db has stored the etcd snapshot, means all the key value that we want to store. Then we stop the control panel kubelet. We know that a control panel kubelet is of maximum usage because all the nodes present in the control panel are static nodes. So all the static nodes are managed by the kubelet. So if we stop the control panel kubelet, all the things, API server, etcd, all the things will stop working. So we have directly attack on the directly attack on the control panel and all the Kubernetes cluster. So that's why we have stopped the control panel kubelet. So the Kubernetes will stop working. So that's why we have used the sudo command to get the master access and stop the control panel kubelet and delete the etcd file data, all the things that we have deleted. And then we use a container to restore the backup that is present in our snapshot directory and in the disk that we have created earlier. Then we use container to restore this. Note here we have to use container to restore all this data, because kubelet, etcd, other commands, all these will not work because we have deleted all the data, because we have deleted the kubelet. So all the things have been deleted. So only containerized container will work, because container runtime environment will present, that is Docker and other things. So only that will work. So we have used that thing to deploy all the things, that is kubelet, all the control panel components. We are using containerized application to deploy all these things. So then only that commands and other things will work, that then only we can interact with API server. So and that's why we have used container to restore our application from the snapshot. Then if we start the kubelet and configure that pods are running, then we get a positive response, and we can see that the pods are running, and confirm that the web service, the application we have deployed, is working successfully. The first part of the job is done successfully. That is, we have created a backup and restored it successfully. Now our second part is to upgrade our Kubernetes cluster with the KubeADM. So the steps we have seen, that first we have to upgrade KubeADM, then we have to upgrade control panel components, then network plugins, then go to the Kubernetes packages which involve kubelet, kubectl, and then we have to upgrade the kubelet configuration on working nodes. So we can see that to begin our upgrade, Cube ADM needs to be upgraded from to 1.253, because we know that Cube ADM is used to deploy application. So we are deploying a new version of Kubernetes. So that's why first of all Cube ADM is need to be upgraded. So first we will generate an upgrade plan for the Cube ADM, checking the requirements, the cluster requirements and other requirements, and the upgrade plan of all these things. Then we apply this and upgrade our Cube ADM and click on yes. Then we come to our second step to upgrade our control panel node, kubelet, and other thing by draining the node. So the in this step we have done the control panel node kubelet upgrade, and then upgrade the kubelet kubectl packages that we have seen. That the third step is to upgrade the Kubernetes packages, which include kubelet, kubectl. Then after all this update, there may be chance that control panel components may stop working, or there may be some error or efficiency present in the control panel component. So we can uncordon the control panel component. That is, we can schedule the control panel to start working if it is stop working due to an upgrade, and get the node information to confirm that the control panel component is working fine. So we can check that kubectl get nodes that control panel is working and ready with the version 25.3 that we can see. But note here that the worker nodes are still running on the 24.3 version. Only the control panel component is changed to 25.3. So our last step is to upgrade the worker nodes to the 25.3 version. So here we will drain the worker node 1 to prepare it for upgrading. Draining means deleting all the data present in that worker node, means all the data. So we are doing in this lab step. But if there is some important data present in that node, then we must first perform backup and restore that data. But for this lab purpose, there is nothing important. We can also see that we know that isn't any important data. So we can safely perform this. But if there is something important present in that node, worker nodes, that we have to first restore that, then perform this training process to upgrade these worker nodes. So we have drained the nodes. So we have used the SSH command to drain the content of the node and upgrade the node to the required packages, that is 25.3 version, and restart the worker node kubelet and return to the kube control panel. And then we uncordon the same process, uncordon the worker node to know if it's working fine. So then we confirm that the Uncorded means it will start working, which we can also see there. The given node will be marked. Uh, the uncorded will be marked node as schedulable, that you can schedule and work properly. Then we confirm the worker node is ready and ready with the version 2.25.3 that we can see here. In the same step, we can drain the worker node 2 and use the SSH command to upgrade it to the required packages and restart the worker node's kubelet, and uncordon the worker node 2 to get it scheduled and start functioning, and confirm that all nodes are running with the required version. Similarly, means we have performed the upgrading of the or both the two working nodes and the control panel nodes. So we have seen first how to backup and upgrade the Kubernetes cluster, and then we see how to upgrade a Kubernetes cluster with the kubeadm. First we have upgraded kubeadm, then control panel, network plugins, then Kubernetes packages which include kubelet, kubeadm, kubectl, and then we upgrade the worker nodes using the kubeadm. So that's all for this lab, and thank you.